Good morning, one and all. My name is Nagaraju, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Here now I want to explain about antennas and wave propagation subject. So the prerequisite for this antennas and wave propagation subject is electromagnetic fields and Maxwell's equations. Okay, it is very familiar as EMTL, electromagnetic theory and transmission lines. The main thing, the first regarding this EMTL is first one, EM wave, electromagnetic wave. This consists of the electric field and magnetic field. These two fields are perpendicular to each other and also perpendicular to the plane of propagation. Okay, so it consists of the two different fields, electric field and magnetic field. So these two are perpendicular to each other and also perpendicular to the plane of propagation. So such type of EM waves we are used in the antenna and wave propagations. Okay, apart from these, and we also use the Maxwell's equations, for Maxwell equations. Okay, so this is the prerequisite for antennas and wave propagation subject. Yeah, coming to the course objectives of this antenna and wave propagation subject. So here we have the 5 modules for this subject. 5 units or 5 modules we have. Okay, for these 5 modules we have the 5 objectives and correspondingly we have the 5 outcomes. Okay, so guys, here we have the 5 unit syllabus. Regarding that 5 units we have the 5 objectives and corresponding that objectives we get the 5 outcomes. Okay, now we go through the objectives and outcomes and the syllabus one by one. So the first objective for this AWP subject is understand the basic concepts of antennas. Okay, so now I move on to the syllabus. Yeah, here the unit 1 is named as antenna basics. So the basics of this is patterns, that is nothing but the radiation pattern, beam area, radiation intensity, beam efficiency, directivity, gain, resolution, and all are things which are relates to these antenna basics. So for that, in my objective, understand the basic concepts of antennas. Okay, so by learning these total unit 1, we try to get the explain the mechanism of radiation and distinguish between the different antenna radiation characteristic parameters. So our objective is to understand the concept of antennas, antenna parameters. In our syllabus we go through the antenna basics and antenna theorems and all those things. By that our outcome is to clearly we can understand the radiation pattern and the different antenna radiation characteristics parameters. Okay, so now we move on to the second objective, analyze the characteristics of antenna arrays. Array is group of similar antenna elements. Okay, similar we can very familiar with this array word as group of similar objects or group of similar things. Here I am using the antenna arrays. That means that here I am considering the group of similar antennas or antenna elements. Okay, so what are the characteristics while we are considering the group of antennas? So that is our objective. Yeah, now I move on to this syllabus. Here unit 2 is there, antenna arrays. Okay, so in this condition, yes, I have the basically 2 different type of antenna arrays, that is EFA and BSA. This EFA stands for end fire array. End fire array. And coming to this BSA is broadside array. End fire array and broadside array. Okay, so the basic difference between these 2 arrays is here for this end fire array condition we can get the maximum radiation in the antenna axis. Okay, so if you are arrange the antennas in this axis, we can get the maximum direction in that only. So coming to the broadside array, so the maximum radiation is perpendicular to the antenna array axis. Okay, so we can arrange the same pattern of similar antenna elements Okay, but the maximum radiation occurred is to be deferred for these two conditions based on the provided input. For end-fire array condition or EFA condition, we can give the each and every element input is of 180 phase difference, but coming to this broadside condition, we can give the same input. Okay, for that we get the maximum radiation perpendicular to the antenna array axis. So these two different type of antenna array elements are to be studied in our module 2 or unit 2. So coming to the outcome, course outcome, yes, analyze the characteristics of an element BSA. BSA is broadside array, EFA, end fire array, and modified EFA. Modified EFA is comes to the increased directivity of end fire array, that is Hansen-Woodyard equation. So EFA can be enhanced by arranging the same arrangement with a distance of lambda by 4. And next, binomial arrays. Guys, here BSA and EFA are linear arrays. That means that the input is to be same. Amplitude of the provided input is same. But coming to the binomial condition, we can provide the unequal amplitudes based on the binomial equation. So that can be explained with the help of the Pascal's triangle. Yeah, 1, 1. Suppose if you are use the only one element, that amplitude is 1. Suppose if you are use the two elements, those inputs ratios are 1 and 1. Suppose if you are using the three elements, this one is come here and this one is come here. Here 1 plus 1, 2 comes here. So the amplitude ratios for three elements is 1 is to 2 is to 1. Okay, so this is the non-linear antenna arrays. Binomial arrays is non-linear array concept. Okay, so these are the concepts we can learn by studying our second module or second unit. Yeah, now coming to the third objective. Analyze the characteristics of VHF, UHF and microwave antennas. F is for the frequency, HF is for high frequency, VHF is for very high frequency, and UHF is for ultra high frequency. So here we are using the VHF and UHF frequencies. Okay, and those are applicable to the antennas which are operating for microwave frequencies also. So here we are using the three different type of frequencies: VHF, UHF and microwave frequencies. Okay, so we try to identify the which type of antennas are used at these frequencies. Okay, now I coming to the module 3, unit 3. Okay, so in unit 3, as its name is VHF, UHF and microwave antennas 1. Okay, what are the different types we learned here? As Aggie-Wood array, that means Aggie-Wood antenna, and second one is helical antenna. Third one, yes, folded dipole is also there, and horn antenna. So one is Aggie-Wood, second one is folded, and third one is helical, and fourth one is horn antenna. Okay, so these four different type of antennas we can study in the third module. Okay, now so here we mention the microwave antennas. 4 antennas we can study in this unit. Here Aggie-Wood is for this is named after the two scientists. One is Uda, he invented this antenna, but he explains this in the Japanese language. Later Aggie explains or translates that explanation into the English. Because of his translation, this antenna got the huge publicity. So it is very familiar as Aggie's antenna. Aggie-Wood antenna is familiar as the Aggie's antenna. And here coming to the folded dipole, here for the previous condition or for Aggie-Wood concept, we just use the dipole like this. Okay, so now here Aggie-Wood condition, we got the bidirectional radiation pattern that can be changed by using the folded dipole. So this folded dipole is consist of the two different dipoles. One is the continuous dipole, and second one is the cut at its center. Yes, here cut is there now. So we are combining these two dipoles to get this folded dipole. Okay, so Coming to the helical antenna, here this name is given after its geometry. That means that here we use the helical geometry. Helical geometry. This helical geometry is provided by the coaxial cable input. Coaxial cable's inner conductor is provided to this helical geometry. Because of this geometry uses, this antenna is called as the helical antenna. And the fourth one is horn antenna. Its name is given after its shape. It looks like as a horn. It's like this. So because of its shape, it is in the horn shape. So for that, this antenna is called as the horn antenna. Okay. So guys, yeah, what is our outcome in the course outcome? Third outcome is configure the geometry and establish the radiation patterns of folded dipole, aguda antenna, helical antenna, and horn antennas. Okay. So in the third unit, we concentrate on the four different antennas: aguda, folded dipole, helical antenna, and the horn antennas. That is the our outcome. Yeah, next, move on to the fourth objective. Analyze the characteristics of microstrip antennas and the reflector antennas. So previously we are concentrating on VHF, UHF and microwave antennas. Now in the fourth unit we are move on to the microstrip antennas and the reflector antennas. Okay, so move into the syllabus. Yeah, fourth unit. Its name is VHF, UHF and microwave antennas 2. Okay, so in this unit we are concentrating on the microstrip antennas and reflector antennas. Reflector, yes, flat sheet reflector, paraboloid reflector. Okay, so two type of antennas. One is the microstrip antenna, second one is the reflector antenna. So this microstrip antenna is also known as the patch antennas. The best example is our mobile. Okay, suppose if you purchase a one well-known branded mobile, without SIM card we didn't get any calls. Okay, we can get the calls only by insertion of that particular SIM card. So this SIM is known as the microstrip or the patch. Because of that insertion only this can be works. So similarly, yeah, any antenna can be worked with the insertion of one particular portion. That antenna is called as microstrip antenna or patch antennas. The best example is our mobiles. Okay, so these microstrip antennas are very useful because of its small size, cost is less, easy to replace, easy to operable. Okay, so and it can be suitable to the planar and non-planar regions. So for that, these microstrip antennas are very familiar and very usable. Okay, next, coming to the reflector antennas. Reflector antennas are can be explained with the angle of joining. That means that here I considered the two reflectors 1 and 2. These two are joined with an angle of 180 degrees here. So for that it is termed as the flat sheet reflector. Why? Because it looks like as a single sheet. So for that it is named as flat sheet reflector. Suppose these two reflectors are joined with an angle of 90 degrees. Joined with an angle of 90 degrees, in that condition it is called as the square corner reflector. Square corner reflector. Okay, suppose other than 90, so that means 60, 45, 30 like that. So simply it is called as corner reflector with an angle of 60, corner reflector with angle of 45, corner reflector with angle of 30 degrees. Based on that angle, that reflector can be nomenclated. Okay, so here one more antenna is there in reflectors, that is paraboloid reflectors. Yeah, it is more preferable now. Our D2H, direct to home. Okay, all the things are used these paraboloid reflectors. Okay, na? So in the fourth unit we concentrate on the two different type of antennas. One is the microstrip antenna Example is our mobile. Second one is reflectors. In that, paraboloid reflector is there. That's example is D2H or direct to dish antennas. Yeah. Now coming to the fifth objective. Understand the basic types of wave propagations. What is this propagation? Simply it can be termed as the traveling or a transmission. Okay, so the wave is to be propagated or the wave is to be transmitted, the wave is to be traveling. Okay, in which manner? Here in our syllabus we have the three different modes of propagations or three different type of transmission ways. Okay, so that one is, first one is ground wave propagation, second one is space wave propagation, third one is sky wave propagation. Okay, so in the fifth unit we mainly concentrating on the waves propagation. Okay, so three different type of propagations we have. Okay, suppose that propagation is very near to the earth's surface or in the atmosphere region, so that is called as the ground wave propagation. Here we can use the very low frequency or medium wave frequencies. For that it is termed as the medium wave propagation. So coming to the space condition, space and sky waves are operated in the ionosphere and tropospheric regions. Further, those are named as based on their region transmissions. Okay, so guys, the outcome of the fifth unit or fifth module is analyze the ground wave, sky wave and space wave propagations. So three different propagations we have. We can easily distinguish between the characteristics or frequency ranges, and where we can use these ground wave propagation is mainly used for the local applications. That means the lower ranges. Okay, so these are used for the longer range transmissions here. Okay, so that classification or that characterization is to be observed by our fifth unit. Okay, so these are the course objectives, 5 objectives and 5 outcomes based on our 5 units syllabus. Okay, so the preferred textbooks for the antennas and wave propagations are JD Cross, or simply it is John D. Cross. It is in white and blue combination pad, and next Balanis red color pad, and most familiar is K.D. Prasad. Okay, so these three textbooks we will follow, or we mostly prefer to get all the syllabus of antennas and wave propagations. Okay, so guys, now I want to give the introduction about the antenna basics of first unit. Okay, so first thing, we can observe all the things. The first one is, what is the definition of antenna and what is its application or what is its purpose? Antenna is a device. Yes, mainly it is used for the two applications. One is send the data and receiving. So which data we can send here? We didn't send any data. Here we can transmit or we can send the EM waves. Okay, so send and receives the EM waves for the wireless communication. Okay, so simply we can term it as antenna is used for the transmission of EM wave and the reception of the EM wave. Okay, suppose if antenna is purely used for the transmission or a transmitting condition, that is called as the transmitting antenna. If antenna is used for only receiving purpose, that is called as receiving antenna. Suppose if any antenna can be used as transmitting and as well as the receiving, that is called as the duplex. Okay, so the next parameter is radiation pattern. Radiation pattern is very important characteristic of the antenna. So what is its definition? Radiation pattern, simply it can be represented in the graphical manner, or it can be represented by the mathematical function also. Mathematical functions. So suppose if you are mention the sin x, so we can draw the graph like this. Suppose if I mention the cos x, cos theta, we can draw the graph like this. So that means the graphical representation is to be drawn based on its mathematical representation. So the guy's radiation pattern is also defines based on the two parameters, are in the represented in terms of the two manners. One is the graphical representation, second one is the mathematical function. So these two are representing the radiating power in the space. So how could we give the definition for this radiation pattern? The graphical representation or the mathematical function of the radiation properties or radiation parameters expressed in terms of the space coordinates or in the space. Okay, so what is its importance? It shows the strength of the radiated field in the different directions around the antenna. Suppose if you are considered the directional antenna, so in that condition we can get the maximum transmission in one direction. Suppose if you are considered the isotropic antenna, that can provide the radiation equally in all directions. So based on the considered antenna, that radiation pattern is changed and that radiated field is to be changed and the directions also changed. So these characteristics are clearly analyzed by this radiation pattern. Okay, so I hope you understand the CO's course outcomes and course objectives of antenna and wave propagation subject. Okay, so in our next class we clearly go ahead with the antenna parameters with the definitions, equations and proper explanation. Thank you.